In this video, we provide a lesson overview of lesson 8.2, which is about testing a claim about a proportion. These slides are based on slides provided by Pearson to accompany our text and modified by me for our course. So this is the second section in 3 sections from chapter 8 that we're going to cover over hypothesis testing. In 8.1, we studied the basics of hypothesis testing. We talked about the critical value method and the p-value methods in general. And we actually looked at a couple of examples for sample proportions or population proportions, in 8.1. But we're going to get into more of the details of testing a claim about a proportion in lesson 8.2. This is the 8th chapter in Essentials of Statistics, 6th edition by Mario Triola. So here are the key concepts. So this section describes a complete procedure for testing a claim made about a population proportion P. And we're going to do this with hypothesis testing in a number of ways. We're going to use the p-value method. We're also going to use the critical value method. The methods of this section can be used with claims about population proportions, probabilities, or decimal equivalents of percentages. We'll also talk briefly about the confidence interval method, but we're not going to focus on that because the p-value method and critical value methods are consistent with each other and they're going to give you the same answer every time. But we'll talk about that when we get there. Now, this lesson is split into 2 parts. The first part involves using a normal approximation to a binomial distribution, or using a normal approximation to that sampling distribution of the sample proportion p hat. Those are pretty much interchangeable. We talked about doing that in lesson 8.1. We're going to continue to do that here in the first part of lesson 8.2. This serves us all well as an introduction to basic concepts, but it's not a method used by professional statisticians. So while we will do this in order to make sure we understand hypothesis testing, if we want to be more accurate, we're going to have to use a binomial distribution. So part 2 will deal with getting the exact answers using binomial probability distributions. This will require the use of technology most of the time. If our sample size is relatively large, technology will be necessary in order to be efficient. And again, it's going to lead to more accurate answers. This would be the method used by professional statisticians. Now, we're not going to have access to all of the technology that they would typically use, but with Excel, we'll be able to compute all of the necessary binomial probabilities and come up with the same answers as professional statisticians come up with, just using tools that we have available to us. So here are our learning outcomes. The first 2 are associated with part 1. So in the first learning outcome, I will want you to be able to describe the requirements for the normal approximation methods. And the normal approximation methods include using the critical value method and the p-value method to test a claim about a proportion. And here we're using the normal approximation to the sampling distribution of the sample proportions in order to test this claim. Now, in our second learning outcome, we're going to test a claim about a proportion using confidence intervals. But then we'll also explain why the confidence interval method does not necessarily lead to the same conclusion as the critical value and p-value methods. So with that in mind, I'm going to recommend that we use the critical value and p-value methods when we want to test hypotheses and use that confidence interval when we're just interested in estimating a population proportion, as we did in chapter 7. So those were associated with part 1, where we're using that normal approximation to the sampling distribution of the sample proportions, or the normal approximation to the binomial distribution. In part 3, or not part 3, but in part 2, where we're covering learning outcome number 3, we will learn how to use binomial probability distributions to test a claim about a proportion. This is the exact method, and we actually did this a little bit back in chapter 5 when we studied the binomial probability distribution. We just didn't call it hypothesis testing back then. So that's the plan. I'll see you in the next video to start part 1, which is about the normal approximation method for testing a claim about a proportion.